let's try to solve this problem here. Initially, the RMS speed of an atom of a monoatomic ideal gas is 250 meter per second. So they give you the RMS speed of an monoatomic ideal gas atom. Okay, so let's write it down. VRMS is equals to 250 meter per second. No unit conversion required. Everything is in SI unit. That's good. The pressure and volume of the gas are each doubled. Okay, so what you're going to see is that the pressure is going to be doubled. So the new pressure will be equals to 2 times of the old pressure. At the same time, you see the volume are also doubled as well. So the new volume will be 2 times the old volume. Okay, while the number of moles of the gas is kept constant. So that means by the new number of mole will be equals to the old number of mole, because you don't do any changes to the number of mole of gases. Okay, so now they say calculate the final translational RMS speed of the atom. So means by this RMS speed here will undergo some changes due to the change of pressure and volume. So the new RMS speed will be VRMS prime, and we are interested to know what's the value over here. Okay, I believe you can see clearly that there's an old situation, then you manipulate, then there's a new situation. So if it's an old and new situation, what we're going to do, we're going to handle it like a ratio question. So we're going to go through the 3 steps to solve a ratio problem. So first step, we are going to determine the relationship between the manipulated variable and the responding variable. Okay, so for this situation, what are we changing here? I believe it's clear that we are making changes to the pressure, we are making changes to the volume. But what is the response to these changes? Okay, due to this change in pressure and volume, what is the response for the gas system? Well, we see that the response will be there's some changes to the VRMS of the gas atom. Okay, besides that, we should also write down what do we keep constant. What do we keep constant here is the number of mole. Actually, we're keeping a number of mole constant. So if number of mole is constant, we know that number of mole is actually just number of molecules divided by Avogadro number. So because of that, if this number of mole is constant, we should know that Na, Avogadro number, is constant as well. So our number of molecules should also be a constant as well. Okay, so this is something that we know should be constant, the number of mole of gas molecule and also the number of gas molecule. Okay, so now we have determined the relationship between MV and RV. Let's see what equation can relate all these variables together. You have P, you have V, you have VRMS, and you have the number of moles or the number of gas molecules. If you refer back to our rectangle mind map, you have pressure, you have translational kinetic energy, you have temperature, and you have VRMS. Okay, so over here, as you can see, we are manipulating the pressure and volume. So that's the top left corner of the rectangle over here. Next, you have your volume. Well, volume is not existing in this rectangle over here. Let's continue. You have your VRMS. VRMS is on the right top corner of this rectangle over here. So I believe you can see that we are actually going to focus on this side of the rectangle here. So this side of the rectangle, again, there's 2 equations. There's PV is equals to 1 over 3 and M VRMS square. That's the first equation. You also have P is equals to 1 over 3 rho VRMS square. So between these 2 equations, we are probably going to pick the first one, because first one does have number of gas molecules inside and the mass of one gas molecule inside. And we know that from just now, the conversation just now, this should be constant. And because we are not changing the monoatomic gas that we are discussing right now, we are not changing to diatomic, we are not changing it to polyatomic, we know that the mass of one gas molecule should be the same. We are not changing the gas molecules that we insert inside the system. So the M here should still remain constant. Okay, so the first one will be the first equation here will be a suitable equation for us to use. So PV is equals to 1 over 3 and M VRMS square. What are they interested in? They are interested in the final translational RMS speed. So that's VRMS that they are interested in. Let's make VRMS as the subject and bring everything to the other side. So you have 3 PV over NM with a square root over here. Okay, so that's us determining the equation that we are going to use later when we take O nu divided by O. Okay, the second part of it is to find the relationship between old and new. Okay, relationship between old and new. Well, actually, we have already done it earlier, but I'm going to just write it down very briefly. So look at the equation that you have here for P, V, N, and M. Find what's the relationship between the new P and the old P. What's the relationship between the new V and the old V? What's the relationship between the new N and the old N? What's the relationship between the new M and the old M? Okay, we know that we doubled the pressure, we doubled the volume, but we kept the number of gas molecules the same because we are not adding in any gases, we are not removing any gases, and because we are not switching out the gas to another kind of gas, the mass of one single molecule should also be the same. So this should be 1, 1. Okay, so that's simple, just finding what's the relationship between pressure, volume, number of gas molecules, and mass of one gas molecule between the old and new situation. Once we are done with that, we can proceed to do the last step, which is taking the new divided by the old. Okay, so in that case, we are going to take VRMS, the equation that we have, but in the new version, so it's square root 3 PV over N M divided by the old version. The old version will be VRMS. Old version will be 3 PV over NM. Okay, so we are taking just this equation, the equation that we've seen earlier. We prime everything to say that it's a new situation. Then we don't prime anything for the old situation. Okay, once we have done that, what do? We can substitute all the prime with the things that we have, the relationship that we have determined in step 2. So we replace P prime with 2P, replace V prime with 2V, replace N prime with N, we replace M prime with M. Okay, so we replace everything with the old version of things. So once you reach this part, I believe you can see that there's plenty of things that can be crossed out. 3 can be crossed out, P can be crossed out, V can be crossed out, N can be crossed out, M can be crossed out. So what we have left here is 2 times 2, which is 4. So square root of 4 will become 2. So we see that VRMS new divided by VRMS old is just equals to square root of 4, which is 2. Which, if we bring the VRMS old to the another side, it should be 2 times of VRMS old. And we know that the old VRMS is 250 meter per second. So 2 times 250 meter per second allows us to determine the new VRMS. The new VRMS should be 500 meter per second. So that's us going through the 3 steps of a ratio problem in order to determine the new or the final translational RMS speed of the atoms.